All right, let's talk about one of the toughest ATPL subjects out there, air law. But here's the thing. We're not going to just memorize a bunch of rules. We're going to break down the logic behind them so you can stop cramming and actually start understanding. Okay, let's get into it.
So let's put you right in the pilot's seat. You're on final, a critical phase of flight, and suddenly your radio's dead. You look at the tower and see a steady red light aimed right at you. What are they trying to tell you? This isn't just some abstract exam question, right? This is a real-deal situation where knowing the rules is absolutely make or break for safety.
So what's the call? A steady red light means give way and continue circling. It's a super clear, non-verbal command from ATC telling you to hold your position and avoid a potential conflict on the runway. It's like speaking a secret pilot language, one that's crucial when your radio's gone silent. And that's exactly what we're going to do in the next few minutes. We're going to build that mental framework for air law because, when you really get the why behind a rule, the safety logic, the details just naturally stick. So let's build that framework, starting with the rules that let us fly all over the world. So before our plane even leaves the ground, we have to understand the huge global agreements that make international flights even possible. These are like the universal rules of the sky, the absolute bedrock of the entire airline industry.
So everything, and I mean everything, in international aviation is built on this one idea, the freedoms of the air. Just think of them as permissions, like handshakes between countries that let airlines fly and do business across borders. Without these, that flight you took last summer, it just wouldn't happen.
Let's break down the big ones. The third and fourth freedoms? That's your classic round trip. Think of it like British Airways flying folks from London to Madrid. That's the third. And then flying them back from Madrid to London. That's the fourth. Simple enough, right? But the fifth freedom, that's where things get really interesting and strategic. Imagine that same flight then continues on to Rome. The right for British Airways to sell a ticket just for that Madrid to Rome leg. That's a super powerful fifth freedom right.
Okay, and here's a big one for your exams. So listen up. Examiners love to test this. You got to remember, the fifth freedom is often called beyond rights. Pretty logical, right? Because the flight goes beyond that second country. Now, the right to fly purely domestic routes in another country, say a U.S. airline flying between two cities in Japan, that has a totally different name, cabotage. Keep those two separate in your head.
All right, international permissions are sorted, our flight plan is filed, and now we're at the airport. The aerodrome itself is this incredibly structured place where every single light, every marking has a super precise meaning. And that's never more true than when the visibility starts to drop.
So on a normal day, the taxiways are pretty simple. You've got your blue edge lights, easy. But when visibility tanks and they call low-vis procedures, or LVP, that's when the system gets a major safety boost. Suddenly, bright green centerline lights pop on to give you a clear path to follow. And as you get closer to the runway, they even start alternating green and yellow, just to really get your attention. It's a perfect example of how safety is layered.
So let's put you back in the cockpit. You're following those green centerline lights, it's foggy outside, and you see this bright, lit-up red bar across the taxiway. What's the specific condition that requires ATC to use this system? What are they trying to prevent? The magic number you need to remember is 550 meters of runway visual range, or RVR. If the viz on the runway drops below 550 meters, those lit stop bars are now mandatory. They're a physical, impossible-to-miss do not cross sign that ATC controls. It's literally the last line of defense against a runway incursion. So, the big takeaway here? RVR less than 550 meters equals mandatory stop bars. Got it?
Okay, now we're cleared for takeoff, we've had our flight, and we're on approach to land. The runway itself, it speaks a very precise visual language with its lighting system, basically guiding you home. Every single color, every position is telling you something important.
Let's focus on those centerline lights as you're touching down. For most of the runway, they're just plain white. But as you get closer to the end, they start giving you critical info about how much runway you have left. In that last 900 to 300 meters zone, they start alternating red and white. And for the final 300 meters, all red. It's this simple, visual countdown right there on the pavement. You go from white to mixed to red. You always know where you are.
All right, here's one that trips up a lot of students. The displaced threshold. You'll recognize it by those big white arrows painted on the pavement leading up to the main runway markings. So what's the deal with it? Well, you can use that area for your takeoff roll, but you absolutely, positively cannot land on it.
It's displaced for a reason, usually to keep you clear of some obstacle on the approach. So just burn this into your brain. Takeoff? Yes. Landing? No.
All right, we've departed, we're climbing out, and now we're entering the sky's invisible architecture, the airspace itself. You really have to understand its different classifications because that tells you what rules apply, who you need to talk to, and what kind of help you can expect from ATC.
Now, this table can look a little intimidating at first, but for us in the airline world flying IFR, we're mostly worried about classes A through D. The key is just to see how it progresses. Class A, that's for IFR only, no VFR traffic allowed, period. But as you move down to B, C, and D, the airspace gets a bit more relaxed, letting in VFR traffic. The main difference is that VFR traffic gets traffic information, but not full-on separation from other VFR planes.
So how on earth are you supposed to remember all those classes in order? Well, here's the classic mnemonic every pilot learns. All big cats don't eat fat goats. That's A, B, C, D, E, F, G. Trust me, that silly little phrase is going to save you some precious seconds in the exam.
Okay, so we're cruising along. How do we make sure we don't run into traffic going the opposite direction? That's where the semicircular rule comes in. And honestly, it's a beautifully simple system. Here's how it works. If your magnetic track is anywhere easterly, so 0 to 179 degrees, you fly an odd flight level. If you're heading westerly, you fly an even flight level. That's it. East is odd, west is even. And just like that, you've got thousands of feet of vertical separation baked right into the system.
So far, it's been a perfect flight. But what happens when things don't go according to plan? This last section is all about handling those non-normal situations, where knowing the exact procedure isn't just important, it's everything.
Remember that radio failure from the beginning? Let's take it up a notch. This time, you're in the clouds, what we call IMC. If you lose your comms now, the procedure is super specific. You have to maintain your last assigned speed and level for exactly 20 minutes. Now, why 20 minutes? It's not a random number. It gives ATC this predictable window of time where they know what you're doing, so they can clear all the airspace around you. After that 20 minutes is up, you then go back to your filed flight plan. That 20-minute rule is a massive safety buffer.
Okay, weather minima. This is where exams love to lay traps, so let's nail down 3 key points. First, special VFR, or SVFR, is something you can only get inside a control zone. That's the bubble of airspace right around an airport. Second, to be considered VMC inside that control zone, you need 2 things: a cloud ceiling of at least 1,500 feet and 5 kilometers of visibility. Both. And finally, to get that SVFR clearance when things are worse, you just need 1,500 meters of visibility, but you have to promise to stay clear of the clouds. Getting those numbers right is absolutely vital. And really, all of this brings us back to the most important point of all. Every single rule we've talked about, from light signals to airspace to emergency procedures, it's all there for a reason. Each one is a link in a safety chain that's been built over decades. If you can just focus on understanding that logic, the memorization part becomes so much easier. So we've covered a ton of ground, literally from the ground up into the air. You've got a solid framework now for the rules. But what happens when you're flying an ETOPS route, maybe 180 minutes, that's 3 hours, from the nearest airport, out over the middle of the ocean? The rules, the procedures, they change again. If you want to dive into advanced stuff like that and get more of these practical exam tips, you know what to do. Make sure you subscribe.